Nice to meet you. Today we are going to look at how uh, IPv6 works to understand and to explain IPv6. What is it? How is it different from IPv4? And how to configure on network devices such as computers and routers. So let's get started. First of all, an IP version 6 is different from an IP version 4. You know that an IP version 4 is a number that is 32-bit, and those 32-bit you divide into 4 parties separated by a dot, and each party was 8-bit. So you also know that in IP version 4 we have a network part that identifies the network or the subnet, and we also have the host party which identifies each individual host in our network. So to differentiate or to identify which part is the network party, which part of the IP address is the host part, we use subnet masks to tell us the network part and host part. So in IPv6, it's a little bit long. Instead of 32-bit, we have now 128-bit address. So you can write all those 128 bits, and we construct 8 parts. In IPv6, we construct in 8 parts. Just like this here, we have part 1, part 2, part 3, part 4, part 5, 6, 7, 8, and each part contains 4 hexadecimal. We will see hexadecimal in a moment. So we have first hexadecimal, this is hexadecimal, 4 hexadecimal is in the first part, and those hexadecimals are separated by double column. So in IPv4, if we let's go back, we normally work in decimal and binary. So in IPv4, we work on decimal and binary. So we know that how to convert from one to another. For example, if we have this IPv4 address which is class C 168.1.0/24, then you know that this /24 is the subnet mask, and the subnet mask, this means that this 8-bit here, 8-bit in the second, and 8-bit in the third, total is 24-bit. So these first 3 numbers identify the network, which is 192.168.1, and this one identifies, the last one identifies the host. All right, so the first usable address for the host starts .1, the next usable address .2, and so on and so forth. So in this case, this is now written in decimal. We can also write this one into binary using this conversion table: 128, 64, 32, 16, 8, 4, 2, 1, so that you can convert this 192, this decimal number into binary. So 192 is 128 plus 64. If you add these two, you will get 192. So 192 is going to be like 192 is going to be like you have 1 1 and then all zeros, 1 2 3 4 5 6. So each number we can form an 8 bits. All right, and so this is 192. We can also write 168. 168 is coming from if you add 128 plus 128, then 68, you need 40, and 40 is 32 plus 8. So 168 is going to be so 1. We don't need 64, so it is 0. We need 32. We don't need 62. We need 8, and then we don't need the remaining. So this is the way you write convert an IPv4 decimal into binary. You can also do the reverse and convert this. If you are given this decimal, you can convert it back to, I mean, if you are given this binary, sorry, you can convert it back into decimal. So this was an IB version 4. So IB version 4, you have 32 bit. The first part is 8 bit, then dot 8 bit, dot 8 bit, dot 8 bit. Total is 32 bit. Now let's go to an IP version 6. Most people, when they are new in IP version 6, they got intimidated by these 128 bits, but as we go on, it is going to get very easy. It's not that hard. So we say that in IP version 6 we have 120 bit. So in this case we have we can have hexadecimal because if we wanted to write 128 bit, it's too long. Okay, uh, actually it is too long, 128 bit. So writing it becomes very hard. So the way we do that, we write it into an hexadecimal. So in hexadecimal, when we say hexadecimal, this is going to be a base 16 number. So it has 16 numbers. Like you know that in decimal, it is a base 10 because we have 0 up to 9. So we have 0, 1, 2, 3, 4, 5, 6, 7, 8, 9. So that's a base 10. Binary is a base 2 because we have only 0 and 1. So I think it would be good to write also this one because we have these 3 numbering systems. So decimal, it's called base 10 because we have 0 through 9, and also binary, it's going to be like base 2 because we have only 0 and 1. This is the digital. But in base 16, it's going to be like we are going to like extend this decimal from 10 numbers to 16 numbers. So we add characters like, okay, we have like the decimal, we have 0 through 9, okay? But because that's the end, now we to get 60 up to 16 numbers, then we add a to f. So if you count from 0 up to f, you are going to have 16 characters. You have 0, 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. Not 10, sorry, 10 is going to be a. When you end with 9, the next 10 is going to be the letter. It's going to take the letter A. So when you are 9, you have now, let me start again, 0, 1, 2, 3. Using your fingers, you can count 0, 1, 2, 3, 4, 5, 6, 7, 8, 9. A, B, C, D, E, F. That's going to be 16. So in decimal, we have those 16 characters or base 16. So having understand that right now, so we say that IPv6 we have 128 bits. So what we do is that what we are going to do is that each character out of this 16. So it's going to take it's going to take 4 hexadecimal characters. Okay, so if you have 0, for example, in binary, because 0 now is hexadecimal. Now we are not working on decimal, we are working on hexadecimal and binary. So 0, when you have 0 from this hexadecimal in binary, it's going to take 4 numbers like this. Then the next one is 1, then it's going to be 0 0 0 1. Then the next one is going to be 2, which is going to be 0 0 0, let's say 0 0 10. The next one is 3, which is going to be 0 0 11. The next one is going to be 4, which is going to be 0 0 100, and 0 100, and so on and so forth. So you can convert each, then you can continue like this until you reach the last or the final hexadecimal character, which is going to be F, and F is going to be all 4 ones. So for example, in hexadecimal, if I have 4 hexadecimal characters like 1 2 3 F, so this is an hexadecimal group of number. Now if I want to convert into a binary, they are going to, because we say that each hexadecimal character is going to be converted into 4 binary numbers. So 1, we found it to be 0 0 1, so we have 0 0 0 1, and 2 is 0 0 10, and 3 is 0 0 11, and F is all 1. So we have this hexadecimal character is now converted into how many bits? 1 2 3 4 5 6 7 8 9 10 11 12 13 14 15 16. So what we are going to do is that we say that IPv6 is 128 bit. So if you divide 128 by 16, what are you going to get? Let me get my calculator. So using this calculator, we said 128 divided by 16, it's going to be 8, right? So here we have 8, right? So instead, let me write, instead of writing 128 bits, we can now write let's say 8 hexadecimal parts, each of 16 bits, like we found right now. So the first part, each part is going to contain 4 hexadecimal characters, and when you convert it into binary, it's going to be 16 bits, right? So that's why we can now shorten. Instead of writing 128, we can now write only 8 parts separated by double colon, and each part, hexadecimal part, is going to contain 16 bits. So let's take an example to clarify this more. So here we have a table. This has 16 hexadecimal characters, converting each one into binary. And what we can do is that we say that each hexadecimal character from 0 up to F can be converted into a 4 binary numbers. So for example, if then we can have, like the way we explain it right now, we're still in 8 parts. So this is 8 1 2 3 4 5 6 7 8. So we have 8 parts. Each part contains 4 hexadecimal characters, and when you convert it into binary, it's going to be 16 bit. So this part is 16 bit double colon 16 bit double colon 16 bit double colon 16 bit up to the last one, and if it's in total it should be 128 bits. And now instead of writing 128 bits, which is too long, we can now write these hexadecimal characters and shorten the IPv6 like this. Still, it is too long. Still, it's too long. So the question is, can we have still other possible ways we can still shorten? The answer is yes. So there are certain rules that you need to follow. So the first rule is that you can omit all leading zeros in each part. And then the next one is that if you have consecutive all zeros, hex zeros, you can replace with a double colon, two double colons, but you are allowed to do that at only once in the IP address. So in the previous, this was our IP address, which was very long. Now using these two rules, we can remove all the leading zeros. For example, this part here, it has two leading zeros, so we can remove and we can only retain one A. Also, the last one we have 000C, so these three leading zeros can be removed, then we can only retain the letter C. And if you see this section, there are all zeros, so that we can remove, because they are consecutive, they are coming one after another, we can remove all of them, and we can replace with double colon twice, double colon. So this is the way we write. So now our IP address becomes again very short like this. Now we can manage it, we can write it, we can configure it. Right. So you see all these hex zeros was replaced by this colon, the double colon, then double colon, two double colons, and all leading zeros in the blue has been removed. So you can use those two rules to shorten your IPv6 address. Now we have some understanding on IPv6 structure. Let's go to the next slide and talk about some types of IPv6. In IPv4 we had public IP addresses, we had private IP addresses. So in IPv6 we have similar situation, but because IPv6 the number of IP addresses we can get are so abundant and so huge, we don't need to do net in here. So the IPv6 addresses are more than enough for each organization in the world, and we can use one type of public of IP address. We can use the public for even internal in the internal organizations, or when routing advertising through to the internet. So because they are so huge, so we don't have limitations we had in IPv4 in the past. So we have one type, we have global unicast addresses. These are like if you compare with IPv4, they are similar to public IP addresses that are routable through the internet. They start with two with this hexadecimal. So /3 means that the first three bits is going to be it's going to be like you have to be using 2 or 3. So if you go back to table, the first three parts, so if you look to in binary, it's going to be, so the first three parts is 001. Also 3, the first three parts is the same 001. They are different in the fourth bit. That's why we say /3. It means that the first three bits should be this. So the number will start with either 2 or 3. So in global unicast addresses, they start with 2. That's why we say /3. They are routable. You can advertise this IP address to the internet. They are allowed. That's to manage and register. You need to go to internet assigned numbers authority, so that they work with regional internet registries. Like in Africa, we have Afrinic. Then those Afrinic, they also work with the service providers on the continent in Africa. then those containers, when they are provided surface to end users like telecom operators, they also assign small blocks of those IP addresses. In IP version 6, it's not going to be small, it's going to be so huge. So that this telecom operator can use this registry both when going to the internet and also in the internal organizations like private IP address, because this block is so huge. So this international organizations, they assigned this block slash I to Afrinic. Afrinic then subnetted this one and assigned this slash data to the ISP. Then this ISP again subdivided those block subnet, and because it has so many customers, each customer get his slash 48. So now we have this prefix in IP46. We call this prefix. Uh, Now let's subnet, because this telecom operator, when he has this prefix, it's like one network. So they can use it to address only one network, because they have so many networks, so many routers inside. They need to also subnet this part. So let's go to subnetting, how to subnet an IP version 6. So this is the prefix we bought. So this telecom operator, we are simulating that we are in this telecom operator now, and we have purchased this slash 48 prefix. We need to subnet because we have hundreds of networks in our organization. So what we do that is that we say that an IP version 6 is 128 bits. So if we purchase it slash 48, out of 120 bit, we are left behind with 80 bits to work with, right? So normally when you are subnetting in IP version 6, the 128 bit is divided into two parts: 64 for the prefix and 64 for the host. So in IPv6 we also call host address, we also call interface ID. So this is the way we do. So in the prefix we need 64 bits, and so we divide equally 64 for the prefix and 64 for the interface ID. So when we do that, because we have 48, to get 64 for the prefix, for this prefix, we need to add 16 bits to get a slash 64. So those 16 bits we are adding will now form the different subnets. Now, because for the first subnet we have this prefix, this was the prefix, and this is the subnet part. We started from the first 0001. The next one we have 002, 003. So you can see that we can reach up to 9999. Okay, so those are huge. You can see we have almost 10,000 subnets. Okay, we can have almost 10,000 subnets. So those are more than enough for almost all organizations in the world. So from this prefix we purchased, we have now formed 4 subnets. We can continue those subnets as we wish, so that when we are working with IPv6 environment or configuration, we can use different terminologies. For example, these subnets we have created, we can call it subnet prefix. The prefix we purchased it from the registry organization, we call it a site prefix. They also buy registry prefix from uh, Internet Number Authority, assigned numbers authority. So now we have understood global unicast addresses and how to subnet them like this. Let's now go to how to assign those subnets to our networks. Because if we have subnets, the next step is to assign those subnets to our network. So we have different options in IPv6 to assign the IP address, the subnet mask or the prefix mask, the default gateway, and the DNS. We have different options. One option is similar to DHCP for in IP version 4, assigning the prefix and the host. And also we have other mechanics. We also have static like IP version 4, but in IP version 6 we have new methods one is called stateless auto configuration, and the other one is using this format called AUI64 format. So in IPv6, when using this particle stateful DHCP, we use DHCP, the server inside our network, to provide the host, the interface ID part, and the prefix part. Then for these hosts to get default gateway, they get the default gateway from the router on the LAN, on the local link on the LAN, using protocol called NDB, and this is DNS, not DNC. So in stateless auto configuration, it is different. The prefix, uh, the, the devices on the network, they need to get from the router on the local area network using NDB, and when they get when the router is on the link get the prefix using NDP, then hosts can calculate the host part using using the MAC address. Then to get the host portion from the MAC address, we are going to use this format called AUI64 format. We are going to see it in a moment. Also default gateway using NDP. So let's see the options that are available in each of these separately. They because they may look some of them may look new to most of you. So let's go to the first one called stateful DHCP. So this one, you know it. It's similar to IPv4. Stateful means that the list IP address is kept, the information is kept inside the DHCP. So he tracks all the listed IP addresses. It tracks, and then there is the list has expiry date, the list date, and so on and so forth. So it tracks when the list IP address is going to expire. He knows the information. That's why it's called a stateful DHCP. So for hosts or computers on the network to get IP address or default gateway, and also I mean the prefix and the host using DHCP, they are going to send a multicast packet to this destination address. So this packet, they are going to find the DHCP server. Of course, this is going to be relay DHCP server. That is the DHCP server that is on another subnet, maybe in the data center, that is going to assign those IP address to computers in the branch offices. The next one is the stateless auto configuration. So for computers to learn the prefix, the subnet or the prefix length, and the gateway, they are going to use this protocol NDP, called Network Discovery Protocol. So when they get these three information, prefix length, and gateway from NDP, then the interface ID of the prefix, they are going to calculate using AUI64 format. So NDP contains a lot of messages. Two messages that are helpful in stateless auto configuration are called RS and RA, router solicitation and router advertisement. So normally we have local area network, we have a router, and the router is configured to forward IPv6. IPv6 it's enabled. So what's going to do is that the host is going to, all hosts, when they want to learn the prefix length and the gateway, they are going to send this multicast RS message to this multicast address. So this multicast address, all routers on the local area network are going to listen, and when they hear this multicast address, they will know that it is RS message. So this computer is like saying, please, is there any router on the network? Please tell me the prefix language, and if you want it to be the default gateway, please tell me your IP address so that I can use it as a default gateway. So the router responds with listing the prefix and it is IPv6 address, so that it tells please use my IPv6 address as a default gateway, use it. So uh, the, the, the good thing is that uh, if this router knows a lot of different prefixes, he will tell it also to the computer in this array message. Also, if there are other routers on the local area network, they will also respond, because all routers on the local area network will listen to this RS message, destined it to this IPv6 address. Then they will respond with RA, and the RA, all computers will listen RA that is sent on FF01. FF01. So now the computers or the host has learned the prefix, and the prefix length, which is 64, and also the default gateway, which is the IP address of this router. Normally it's the interface that is connected to the computer. Now the final remaining piece is for this host to calculate its IPv6 address. So it is IPv6. Now he has the prefix, which is 64. He has to calculate the other 64, which is going to be the host address. So the way he do that, it's called an EUI64 format, and we know that every host has a MAC address in the data link layer. So what is going to do that, we know that the MAC address is for the 8-bit, and because we have 64-bit for the prefix, we need to get 64-bit also for the host address to get 120 IPv6. So the MAC address is 48. We need to make it 64. So the way we do that, we divide it into two halves. So 48 divided by 2, you have 24 and 24. Then in the middle, we insert 2 bytes or 16 bits to get total of 64 bit. Doing also that, we also do one more step. We flip the 7th bit of the first part. So for example, let's say this is the MAC address of this computer. Now if you calculate, it's going to be for 8-bit, because we have 4 parts, which is 16, then 16, then 16. 16 times 3, it's for the 8-bit. So we need to make it into, let's say 64 bit, right? So to make it 64 bit, we divide into 2 parts. So the division line will come here, 0 and 5. It's going to be, because this part and this part will be now 50 and 50 part is going to be divided into two halves. So in the middle, we are going to insert this 16 bit, call it FFFE. We're going to insert this part FFE. Let's make it red so that we can see it. So we insert FFFE. So now we have 64 bit. It's not yet over. We need to convert the 7th bit. We need to flip. If it is 0, we make it 1. If it's 1, we make it 0. So we flip flop. So right now, the first 4 bits is 1, and then the next 4 bits is C. So 4 bit we have 8. So the 7th bit will fall on C, right? So we need to flip the 7th bit on C. So right now, if we come here, we have 1C as the first 8-bit. So we know that 1 is going to be 0001. And if we go back to our table on IPv6, we have 1 is 0001 and C is 1100, and C is going to be 111100. So we have 1100. So now these are now 8 bits, right? The 7th bit is going to be this guy, 0. If you flip it, then it's going to be like this, 000111. So you flip, which now it's 0, you make it 1 and then 0. So now the first 4 part has not changed. it's going to be 1. We convert it into hexadecimal. Now the next 4 part has changed from 1100, which was C, to 11110. So if you go back to our table, all 1111, so 11110 is going to be E. Now we replace with E. That's why we have here, we have replaced it with 1C. We have replaced 1C with 1E. So you flip the 7th bit. Now we have, this host has now calculated it is interface ID of the host part, with the slash 64 host part. He has already learned the prefix part from the router using NDP protocol. Now this host has now completely created. It is 128 IPv6 address containing the prefix and the interface ID 128 bit. So this is the way stateless auto configuration works using that protocol called NDP, and it uses those two messages. We can also use static. Static is going to be manual. So when you are doing static configuration, you are going to write the entire 128-bit address. The other thing is that you can write the prefix part, which was 64, and then as we have seen in the previous slide, you can calculate the remaining 64 host address or the interface ID using EUI64. So the host can drive it from this MAC built-in MAC address on the Ethernet or network address network card. There are other types of IPv6 unicast addresses. One we have seen was global unicast addresses. We have seen that this is a unicast address because you can assign it to only one interface. Only one interface can receive and send that IP address. And there are other two types called unique local and linked local. So unique local is similar to private addresses in IPv4. They start with FD008, 00/8. This means the first 8 bits must be F and D. And this is the way it's going to form. So we said you start with FD, and so we need to get 64 bit for the host, for the prefix, and 64 bit for the interface ID of the host. The 64 bit for the interface ID, we are going to obtain it using EUI64 64 using for the MAC address. But to get the prefix ID, we reserve it FD, which is the first 8 bit as FD. So out of 64, if you subtract 8, we are going to get 54, right? No, we had 64. If you subtract 8 from 64, you are going to get 56. So 56, you are going to also reserve this 16-bit for the subnet. So 16-bit minus 56, you are going to get 40-bit. This 40-bit, you as the network administrator are going to generate using randomly. You can select just some random hexadecimal characters for those 40 bits. Then completely now you can form the unique local IP address. So they are similar to IPv4 address. But in reality, because IPv6 addresses are so huge, global Unix addresses that you have purchased from the internet registry, your local internet registry, are going to be enough both for the internet and also for the local in the local organization, local area network. The third unicast address is going to be link local. So remember we said here when we are doing stateless auto configuration, the host is going to send this multicast address because in the first time the host has no IPv6 address. So that's why he's requesting the router to advertise the prefix and the gateway, and then to calculate the interface ID using EUI64 format. So the question is, when the host is first contacting the router using NDP protocol, which IP address is it going to use? So we have booted the computer. It's new. It's brand new. It's wanted to contact the router on the local area network and obtain its first IPv6 address. But when it is sending this RS packet, what IP address is it going to use as as the initial IP address? That's why we are now have here something called a link local. So link local is automatically when you put up your computer and you enable the TCP IP version 6, the computer is going to and also the routers and every network device, they are going to automatically obtain the link local. So the link local is what they are going to use when sending the first packets. Okay, for example, using NDB when they want to land the prefix on the network. So all those kind of communications, they are going to use the link local. So the link local is always there. You don't need to configure it. You don't need to assign to computer or routers. They will configure it automatically. Okay, and the all network interface automatically calculated use, and this link local address is used in the first packet transmission. Computers also use it as a default gateway when sending traffic to the next hop. They can use it. So this is it is a structure. They all start with FE80. So the first 16 part is going to be FE80. So to get the total prefix length, we are remaining with 54, and all those 54 bits are set to 0, and then now they have created the 64 bit for the prefix. The remaining is 64-bit for the interface ID of the host, and they calculate as we have seen using EUI64, deriving it from the MAC address, built-in MAC address. So this is the way they are going to calculate the link local. So those are the three types of unicast address. In IPv6, we don't have broadcast IP address. To send a message to a group of devices, we have multicast addresses, and some of them are more common. So we see, for example, when using NDP protocol, when computers wanted to send a multicast to all routers on the local link or the local subnet, they are going to use this multicast address. OSPF version 3 for IP version 6, they listen this hello message using this public IP version 6 address. All computers listen this multicast IP version 6 address. All IPv6 DHCP servers, they listen to this multicast address. So those are some of the common multicast addresses. So in IPv6 again, we don't support to broadcast all 2555 as in IPv4. So let's take some example and see how these things work and have some. So in the previous slides, we have when we purchased the global unicast address, we have created our subnet. So we are going to assign these different subnets into our networks. So here we have, because we have two routers, we have three networks, one, two in the middle, and three. So we have used the first three subnets to assign. So we are going to configure this router and this computer and use some of those methods we have seen in the previous slides, those 4 slides to see. So we go to packet tracer, and to do, actually in this lab we are going to restrict it to only one router and one computer and see how things work. Later in the because this video has got too long, we are going to split into different videos, and then in the coming videos we are going to talk about how to do static routing in IPv6, how to do OSPF in IPv6, how to advertise IPv6 into the internet. And so they are going to be a series of videos that will follow this initial. So this is going to be the first one, which is going to be the basic. So we have this router. So when configuring IPv6 on routers, we go to CLI on the router. We are now using 2911 model of router. So we are going to use, if you can go, but we're going to use the first subnet, which is going to be this one, 2500. The colon double colon 1A4C double colon 333 double colon 001 /64. So this is the 64 part of the subnet. So we again go to the router, the command line interface, no, then we say it enable, to go to the enable, to the enable mode, and then to go to global configuration mode we come here. So let's go to the interface going to the computer is interface gigabit 0/1, and we say first no shot, so that we bring it up. Before we configure IPv6, let's see some of what we have right now. So to see all the configured IPv6 addresses on the router, you need to use command IPv6 show IPv6 interface brief. So right now we have no IPv6, so we need to enable it to use. The way to enable IPv6 on the router and the router to forward this IPv6 over the network, we need to see IPv6 unicast routing. All right. Then we need to assign an IPv6 address to this interface, and we can use stateless auto configuration. We can use static manual. We can write manually. So let's see some of the techniques. So let's see how the router is going to calculate this interface ID using stateless auto configuration. So we are going to teach him the prefix, then using EUI64 format he is going to calculate uh, the the interface ID. So this is not going to be stateless auto configuration. This is going to be a static configuration. So we configure an IPv6 address using static configuration. So in the static configuration, what we are going to do is that let's go to the interface PI 0/1 IPv6 address. So let's write the prefix. The prefix is 2500 double colon 1A4C double colon 3333 double colon 0001, then colon double colon /64. Now we have manually or statically written the prefix part, which is /64. The remaining 64 bit for the host part, we have different options. One, we are going to use EUI64 format. So the router is going to calculate the full 124 28-bit IPv6 address. Right. Now let's now go to do show IPv6 interface brief. Now you see this is our interface going to the computer. Now the router has now two IPv6 address. The first one, remember, we say all IPv6 address that start with FE80 are going to be the link local. So this is, he has calculated the link local. We said, if you remember the structure, this is the first 16 bit. The remaining 54 bit are all zeros. So all zeros, you can shorten them to two double colons, and then the remaining part he calculated. This is the interface ID he calculated using the EUI64 format. This is also the global unicast address we have assigned in this previous configuration. You remember we configured the 64-bit prefix, so this is the 64 prefix, which is the same as what we configured, and then the router has configured the interface ID of the host part using EUI64 format. So the EUI64 format he used in this address is also the same as the one he used in this one. So he calculated using it is in the interface, this interface MAC address. So now the router has public IP address. He can communicate using this one. He can advertise this IP prefix to host using NDP, as we will see in a moment. So this is one way. You can also configure the full full IP address. So let me say no IPv6 address. So we have removed the all IPv6 addresses, as you can see. Now let's say IPv6 address again. So now we are again 2500 double colon 1A 4C double colon 3333 double colon. This is the subnet 001. Now this is the prefix. Now the host part, we are going to use all 00001. Then the last one we are going to use 1. Like for example, because the first host address we can use for the 64-bit interface ID, they are going to be 000 000 000. Then the last one is going to be 001. So this is the first interface ID we can assign statically or manually. So if you shorten this IP address, we say that all consecutive zeros you can replace with a double colon. I mean these first three parties. So they are going to be double colon. Then the last one we can remove all leading zeros. Then you have 1. So this is the interface ID. That's what we are going to configure in here. So we say double colon 1. Okay, remove it. What's no, we don't want to use this one as a link local. Hmm. 2500 1433300 all, I think they are now. Let me say exit IPv6 unicast routing, then interface GI 0/1. Let me assign again. So we don't want to use this as a link, but let me try and see. Link invalid link local address. What is going on? We have all the full 128-bit for that interface. So let me say shut. Let me shut down. Then let me write the incomplete command. Let me use the other interface and say that exit interface GI 0/0, and now write the full IP complete address. We are not missing anything. So let's say /64. So the problem was that you have to write that part /64. So let's see if he set everything as we wanted. Interface brief. Now you can see. So when you are assigning the IP at the full IP address manually, please write /64 so that the router will know this is the first 64 bit is going to be the prefix, and the last one is going to be the host. So this is the way you can assign the interface, the full interface, the full 128-bit IPv6 address, and then it's going to calculate this link local. So this is static. We have also seen how to use static using EUI64. Now let's see how to do how to assign IPv6 address using stateless auto configurations. So we say no IPv6 address. We remove the IP address. Let's see if he has removed. Show IPv6 interface brief. do show IPv6 interface brief. So he has removed it, right? Now, to assign an IP address using stateless auto configuration is, we are going to write that IPv6 address auto config. So now let's see how the interface, how it show do show IPv6 interface brief. Now, as you can see, we only have you know, the problem is that when the router is going to calculate using a stateless autoconfig, there should be another router in the local subnet that he is going to learn the prefix from. So now he has not calculated the IPv6 address using autoconfig because there is no way he can know the prefix because he is the only router on our network. Now, if we add another router, because we have to see this how to do stateless auto configuration, there should be one router, at least one router, who knows the prefix so that he can tell the prefix to other routers when they are using stateless auto config. So let's do like this. Let's go back to this router and set say no IPv6 address. So let's use manual for this guy. Let's go back to the previous one. So let's use this one /64. So do show IPv6 interface brief. So now we have the full IPv6 address. Let's also say that no shut. This is the interface gigabit 00 going to the computer. So the interface going to the other router. Let's also configure it with also using static. Let's say it's interface gigabit 0/1 no shut. Now let's say that also using manual, let's give it the second one /2. So he says it's overlapping, right? We have to use in our topology, we have to use this second subnet, which is 002, because it is a new network, right? So let's use the second subnet 0002. Now it's okay. Now let's say that do show IPv6 interface brief. So now we have configured both interfaces. Now using stateless auto configuration, let's configure the other router and see what's going to happen. Because this router now, there is one router at least from which he can learn the prefix from. So this guy knows the prefix because we have configured manually. Then all other routers can learn, you can use stateless autoconfig to learn the prefix from this guy. So let's go here and configure it manually. So we go to command line interface or CLI, no able conft. Let's go to the interface going to the router 0 gigabit 0/0. Let's first bring it up. Now it's up. Now let's say IPv6 address autoconfig. Then let's say show IPv6 interface brief. Now you can see we have not configured anything on this router. We just say that please configure IPv6 address using autoconfig, and automatically he learned the prefix. He learned this prefix from this router. So he learned the network from this router on the interface he is connected. So this router is going to send RS message or the router solicitation message, and this guy is going to respond with the router advertisement, so that this guy now can learn the prefix from this guy. And then you can calculate the interface ID for this interface gigabit 00 using EUI64 format. So now, if we wanted to see the MAC address of this interface on this router, we can say show interface gigabit 0/0. And if you go a little bit up, this is the MAC address 00D0PA27. So using EUI64 format, we have just explained it. Now he has calculated, he has inserted FFE in the middle of the MAC address to get 64-bit, and then he flipped the 7th bit of the first bar. Now this router has assigned full 128 IPv6 address on its interface. Now let's go to the computer and also assign an IPv6 address. We also have all those options when configuring IPv6. We can configure using DHCP. Right now we don't have DHCP. We can also configure static. Static is too long, so let's use autoconfig. Now you can see he has learned the prefix, and he has using his built-in MAC address, he has calculated the interface ID using EUI64. Also, he has received the default gateway from this router. So this router has advertised it is link local address, and he tells this computer, please use my link local address as your default gateway, which is this one. So this computer has calculated it is link local, and this link local address is this default gateway is the link local address of this router. So this computer using NDB exchange those messages, has multicast messages, has now learned the prefix, calculated its interface ID using EUI64 format, also obtained the default gateway from this router. So I hope this first part was a little bit easier. In the upcoming series of videos, we are going to explore further options like how to do routing in IPv6. And thank you. Bye bye.